Hello friends, welcome to the channel. In this video we are going to discuss the concept of IP routing with single router. That is an important concept of the networking, and it's a form of static or default routing because you are providing the fixed routes to the router. So let's have the implementation steps with a basic introduction of the concepts. So first we have the router. So router is a device that is supposed to connect different networks, and it decides the route by examining the destination address from the header of the received packet. Means if we have the source as A and the destination host as B, so router will decide the next hop or next route where the packet need to be transmitted in for the successful delivery to the destination B. So router may be connected to different routes. So it's the responsibility of the router to decide the best route for the packet to forward, and router uses the routing table for this purpose, means to decide the best way to transfer the packet. And the companies manufacturing the router are Cisco, 3Com, HP, etc. So what is IP routing? After router we have IP routing. So router is supposed to connect different networks, and the process of connecting or sending receiving packets within networks is known as IP routing. We have two types of routing as static and dynamic. Suppose we have two networks, as this is our first network and this is our second network, then we will be using router to connect these two networks, and after this connection or IP routing, these two networks are capable of sending and receiving the data and sharing of resources. But you can also have IP routing within a network with the help of classless subnetting. Means if you are creating multiple subnets within a network, then you may also use IP routing for this type of classless subnetting that is used in most of the growing organizations and universities, institutes, etc. So now this we are going to implement, where we have this as the first network and this is our second network. By network we mean the network ID of these two connected network must be different. So here as we can see, the first network is having network ID as 10.0.0 because this is a class A address. So the network address will be 10.0.0.0. Okay, as we all know, if the host bits are 0, then we found the network ID, and for this network, as the network ID is 20.0.0, so the network address will be 20.0.0. So for routing concept, you must understand the concept of IP addressing, subnetting, next subnet mask, and the network ID, broadcast ID, etc. So here if we have all host bit as 0, then it will form the network address, and here the network address will be 20.0.0, and if we have all host bit as 1, that will be the broadcast address of this network, and if we have 20.255.255.255 means all host bit as 1, then it will form the broadcast address of this network, right? So here this is the first system with host ID as 1.1.1 and the another system with host ID 10.1.2. Okay, so this is our host ID. So I am keeping the IP addresses simple just to avoid any confusion. So here also I am using host ID, as I have only changed the network address. I am keeping the host ID same for this network as well. So here we have 1.1.1 as a host ID, and here we have 1.1.2 as a host ID. Okay, so after this we need to provide one gateway address for every network. Okay, so gateway address is the address that is the path for this network to another network. Okay, means with the gateway address only one network can connect to another network, or we can say that gateway is responsible for converting the packet from one protocol to another. So for this network we can take any unused address. Unused address means the address that is not assigned to any host as a gateway address. For this network also we can use any address that is not assigned to any host in the network as a gateway address, but gateway address must have the same network ID. Okay, so here as we have taken 1.1.1 and for this .2, so gateway can be any other address with network ID as 10. So I am taking 10.1.1.3 as a gateway address of this network and 20.1.1.3 as a gateway address of this particular network. Now subnet mask for all these hosts and gateway will be same for this network as 255.0.0 as it is a class A address. Now another thing we need to know is where the router is connected to this network, means the port where the router is connected. So suppose it is fast Ethernet 0/0 and it is fast Ethernet 0/1. Okay, or you may be connected to another port. So here if this is the port for this network connection and this is the port for this network connection, so we need to configure this connection with this gateway address. So this is the gateway address or the identification number, we can say that, for this port, and for this connecting port means the second port that is connecting this network will be identified by this gateway. Okay, 20.1.3. so for this port, this is the IP address, we can say that, or for this port this is the IP address of the router. Okay, for these systems as well we need to define three things. One is IP address for every network host, means for every host connected to the network we need to define IP address, subnet mask, and third is the gateway. Okay, so for every system, every host, for this and for all systems we need to define IP address, subnet mask and the gateway. So subnet mask and gateway for every host in the network would be same. Means for this system also the gateway will be 20.1.3 and for this system also 20.1.3 will be the gateway. Subnet mask will be 255.0.0.0. So for that will be same for all the systems here. So why we are providing gateways to these networks also, these hosts also, because these hosts only can communicate via this router. Okay, via this connection they can connect to outside world via this router, means these hosts can connect to these the host in this network via this router only, and for this router means to transmit the packet to this router. To transmit packet to this router, they must send the packet to this port, and this port is 20.1.3, means the gateway address of the network. So we need to keep a separate address as a gateway address for every network. Same way this system will communicate through this gateway only. These systems are unknown to the outside world, they are only known via this gateway address. Okay, similarly for these system also we need to provide IP address, subnet mask and the gateway as 10.1.3. right? I hope you understand the basics. So let's begin with the implementation. Here I am quickly adding the end devices. Let's take 4 end devices. For network 1 and network 2, I am also taking 2 devices. You may have some more devices connected to a network. Next we need a switch. So switches within the network. Next we need the connecting cables. So cables, for same device we need crossover cable. For different devices to connect we need the straight through cable. But if you are confused, you may take this automatic connection that will automatically configure the systems with the required ports and connect them with the required cable. Okay, so here we have connected the network, means the network is complete. Let's start labeling them. So here I am providing the IP address as we have discussed, the same IP addresses I am providing 10.1.1 for the first system, and for another system this. I have not provided the IP address, this is just the labeling part. So here also I am providing 20.1.1, and for this I am providing 20.1.2. okay, so what is the network address of this? So network address, for this network address I am labeling it as 10.0.0. okay, so this is our network address, and here also we have the network address 20.0.0. okay, so you can also make the we can say the display more attractive by using the drawing palette. So here is our first network. Sorry, I must use so this is our first network. For another network, let's change the color. So this is our second network. Okay, now our purpose is to connect these two networks. For that I need to have a router. So let's take the router. I am taking the first one. If you are taking any other router with less number of ports, then you need to add the ports to the router, that we will discuss in later videos. So here let's make the connections. Again I am using automatic connection, but it would be connected to fast Ethernet ports. As so if you want to know the connections over here, you can simply turn on the preferences for showing the port labels. So by this you would be able to see the port labels where the connections are made by automatic connection type. So here let's label the gateway. Gateway for this network would be 10.1.1.3 as we discussed. For this 20.1.1.3. okay, so let's start the configuration part. So for this system I am configuring it with the IP address 10.1.1 and the gateway. Subnet, if you see, subnet mask is taken automatically. We just need to provide IP address and the gateway. Gateway for all these system would be same. Okay, they all are connected to 10.1.3. For the second system, change the host ID to 1.1.2, gate network address, subnet mask and the gateway. So gateway is 10.1.3. Configuration of both system is complete. Now let's configure the next system in the second network as 20.1.1.1. Now subnet mask and the gateway as sub.3. For this second system, you must provide the labeling to make the things understandable. Sorry, here the host ID is .2 and the gateway is .3. Okay, so the systems or the host in the networks are configured with the IP address, subnet mask and the gateway. Now we need to configure this router, and for this we need to know the port numbers where the connections are made. So for this router, if you are confused, you can try moving this router. If you are you can see here the connection is made to fast Ethernet 0/0, and for this connection we have fast Ethernet 1/0. You can try or see this by moving this router. So let's configure the router quickly. So go to configure. For this fast Ethernet 0/0, we need to provide the gateway of first network where this port is connected. So firstly we need to turn on this port and provide the gateway, and the gateway for this is 10.1.3 as we have already discussed, 10.1.3. so this router for this fast Ethernet port is configured to this gateway, and host will also send the packet to this gateway. Okay, and for the second port, that is fast Ethernet 1/0, let's turn it on and provide the gateway as 20.1.3 for this second network, and the subnet mask is taken automatically and the configuration is done. Our network is ready. We are calling it static routing because routers both port of the router are configured for two networks and they know where to transmit the packet. If the packet is destined for this network, the router will simply move the packet to the first network. If the packet is destined for another second network, the router will simply forward the packet to the second network. Now just to make the things clear, I am turning off this always show the labels. Okay, so now you can simply see the configuration, or by label you can see the configuration that we have already done. Now let's try sending the packet unit from one host in one network to another network. So we can also try it with the ping command, ping 20.1.1. so I am using the ping command from first system of first network to the first system of the second network, and for first time you may get the timeout as I already told you, but for other three requests we got the success. Okay, so here the connection is successfully set up. Now let's try to ping, or we can also try it with the simulation by sending a simple packet data unit from first system of first network to the first system of the second network, and the status is successful. You can also see this with simulation. Our destination host is this first host of the second network, and the switch will simply send the packet, the received packet, to this. So router has just forwarded the packet depending on the destination address of the packet received. As the packet was destined for the second network, so simply it was transmitted to the switch, connected switch, to this gateway. Through this gateway the router transmitted the packet. Simply now the router has transmitted the packet to first network through this gateway 10.1.3, and hosts are also connecting or passing the packet to the router through this gateway. Okay, so thanks for this watching, and from the next video we will be having static routing with multiple routers, means two router, and dynamic routing with multiple routers. So till then, bye and take care.